welcome from my side. I'm Jens Hunhevicz, and I present you today our work co-authored with David Bucher, Kepeng, Daniel Hall, and Catherine de Wolf. We talked about different aspects of what I will present you already. We saw some of them in previous presentation, and I will introduce to you some of our side work that I was always interested to further pursue. And my main motivation was, at this point, after working so long on blockchain, I'm pretty convinced that there are good use cases for smart contracts in construction, but one particular challenge is cost. So this is a graph that resulting from a study I did some years ago. We implemented the performance-based energy contract and ran it for 6 months. And basically, depending on the actual market price of the cryptocurrency at the moment, this can result in very high costs. So it was between a couple hundreds and multiple $10,000s. So this is, of course, not really feasible if you talk about an application that involves micropayments. So I was always wondering, how can we address this this problem? And I want to introduce you some of my conceptual thinking first, and then also example implementation to kind of underline the process I'm thinking about. So this is also the performance-based contract we implemented some years ago, and I want to drag your attention to how the smart contract is structured. So I noticed over time that there is always a bit the same parts involved in such a smart contract. So on the one hand, we have data that kind of we need to base decisions upon. Then we have some contract logic defining how transaction flows interact with the data. We have, of course, the funds. So there is always some pools of funds or some inflow and outflow of funds in the smart contract. And there is the roles. So who can do which operation in the smart contract, which address has which permission to do to interact with the funds, the contract, or the data. I'm not the only one thinking about this, so there is a lot of approaches in literature that try to address the cost of smart contracts, and you can always kind of map them around on-chain and off-chain. So on-chain means everything on the blockchain, off-chain parts of it off the blockchain. So typical on-chain approaches to cheaper smart contracts are cheaper blockchains itself. They market themselves with low transaction cost. You can move to permissioned blockchains where you have validator nodes and you kind of avoid transaction costs. And then there is like different approaches. So the first one really takes all the parts and moves them on the blockchain. And then some other approaches start to think about, okay, let's move data of the smart contract. So we move data off-chain to IPFS. Some others, like off-chain schemas and governance platforms, they also propose to offload logic of the smart contract to kind of save on cost. So the overall conceptualization is like, first you have all on-chain, and then you would kind of move towards a framework where you individually assess for each use case and each contract, how do you really use blockchain for which part of this contract? So for the lack of a existing name, we named this blockchain governed contract. So you, of course, need to use blockchain in at least one of them, otherwise it wouldn't be blockchain governed. But we really think that you can, it's not really needed in a lot of the cases in construction to have everything on chain. And to kind of explain a bit more tangible how this would look like, we re-implemented the performance-based contract we did all on-chain and thought about, okay, in which parts do we use blockchain and which not. So we came up with one approach. Of course, there is a lot of system combinations possible. We started with one approach that we found interesting. So so that you can make kind of sense of this graph, you find the different parts vertical of the smart contracts: identity, payment, logic, data. And then horizontal is the physical environment, the off-chain system, and then the on-chain blockchain system. So to start with the example, identity, we use both an off-chain system and a blockchain, so we need both user credentials for traditional systems like Web2, username and password, and we also need blockchain addresses for the payments because we decided we still want to have blockchain-based payments. We used Bitcoin for this, and we did this also intentionally to show that even though Bitcoin only supports scripting and no Turing-complete smart contracts, if you think about blockchain governance systems, you can still use them as part of the solution. Then the logic, which is kind of the most important part of a performance or like a smart contract, is particularly interesting. So instead of kind of encoding them and all putting them on-chain in on-chain smart contract logic, we intentionally try to keep the logic off-chain, but still implemented a mechanism so that you can ensure at a later point to check whether the logic was executed as defined. So we used blockchain as a kind of timestamping or like anchoring mechanism for the data, and this was inspired by the Decred blockchain. So they have a system. Decred is another blockchain similar to Bitcoin, and interesting, they have like a governance system attached to it. So Decred Politeia is their proposal system, and interesting about this is how it works technically. They have everything off-chain, and then they have like timestamping mechanisms, so they hash, they create the fingerprint of this proposal, hash them, and put them on the blockchain. And what this enables you is that at a later point in time, you can still recalculate the hash, compare it with the previous hash on the blockchain, and if they match, you know that the data is identical and existed at a certain point in time. So since they have all these timestamping mechanisms available open access, we used their mechanisms, and we created an exemplary governance platform so a user can implement the performance metrics. So for example, in our case, it's a temperature contract, temperature baseline, allowed deviations, and so forth. And then once everyone agrees, you timestamp the contract and you put the hash on the blockchain. So that's what you can see here. So at a later point in time, you could run the validation, and if you don't trust the computation, you could kind of recalculate the hash and check whether you actually used the correct metrics. We did a similar thing for the data itself. The data is time series data from the Nest building at Empa, where I work. So they have very conveniently a lot of open like APIs where we could just take the temperature data as examples. So we also thought it's not really necessary to have a real-time analysis of the performance. So we clustered them now into weekly data sets. We timestamp these data sets so you can then again, when you run the analysis at a later point, see whether you ran the analysis on the right data if you mistrust the process. So the last part is, of course, the logic and the evaluation of the performance and the payouts. And then this is also done off-chain in this governance platform. You kind of just run the computation off-chain. You look at the results. They're displayed graphically. And if you would now mistrust this, you could go back to the individual steps, recalculate the hashes, and see whether it was the right process. And the payments are also not automatic because it's not an on-chain smart contract, but the payments are kind of constructed, and you can just then scan the QR code and sign the payments in an external wallet for the blockchain transaction. So basically what we did, in conclusion, we kind of, what usually is all on-chain in one contract, we kind of torn it apart and then re-evaluated what is really the contribution of blockchain in the individual mechanisms, and then re-implemented them in a slightly different way so we can save a lot of cost because we don't involve all these on-chain transactions. So why do we think it's especially suited for the built environment? Because we usually have known actors, so we can help them accountable. So why pay for on-chain smart contracts in addition? I mean, it can be debated, but I think it's a valid argument. Then time spans vary a lot. I mean, if a contract is for 2 years or 1 year, why pay for on-chain data that is there forever for just a rather small time period, right? And I think one of the most important features is, of construction is its physical nature. So smart contracts, even though they are on-chain and very deterministic and trusted, really depend on the input data. And as long as you cannot assure that the on-chain data, the input data has the same trust level as the on-chain smart contract, it doesn't make sense to pay for the on-chain smart contract. So it's better to kind of match the logic that would be on-chain to the trust level of the input data. So to kind of try to increase both a bit so that you have a more trusted process overall, but not one very trusted and the other untrusted. This doesn't make a lot of sense in a lot of cases. And of course, it's easier to integrate with legacy systems. So in our examples, it's very easy to just replace the Bitcoin payments with a legacy fiat payment system. So just some replacement of certain parts of the code. So key takeaways, I think it's an interesting mental conceptual framework to kind of take this apart and individually think about how to use blockchain in different parts of the contract. You will end up, in our scenario, we ended up with different solutions for that performance contract with different blockchains involved. In our case, we used already 2 different blockchains for different parts. In other contracts, it could be even more or other blockchains. And in our case, we decided to only use it to prove authenticity of data and payouts. I think major benefit, flexibility, and cost savings, especially in the 2 cases we compared now. I know this depends very on the system implementation, so further study would be needed for all system implementations. I'm not sure that would be kind of a big task, but I think some more analysis there would be useful. Semi-automated, longer verification process than on-chain if you really have a dispute, so it would take a bit more time. A lot of additional to-dos, we're working on this, but I think it was worth sharing. Maybe you find it interesting as well and start thinking more in this direction instead of putting everything on-chain. Thank you.